We're going to graph the function m of x equals 4 over x plus 2. I like to always start with my vertical asymptotes. That way I get in the habit of always looking at the denominator first and knowing that that's going to be the vertical line that I graph. Looking at this expression, if I can't solve this in my head for 0, I could always write the equation x plus 2 equals 0 and solve it. Either way, I will find that the vertical asymptote is going to equal x equals negative 2. I'm going to go to my grid right now and graph this vertical boundary line. So you have to have x equals to get the full credit, and it also is a nice reminder that you're going to go on the x-axis to where x is negative 2 and then put a line through it at that place. This is a line the graph cannot touch because it would cause division by 0. I'll move on to the horizontal asymptote next. For the horizontal asymptote, we always look at these lead term stuff. So in this case, we get y equals 4 over x as a way to help us figure out the horizontal asymptote. There's nothing to cancel off here, and we have an x left in our denominator. So when that happens, anytime we've simplified those lead term expressions and there's an x remaining in the denominator, we know that the horizontal asymptote is for very large x's. It's a leveling off behavior. And as x gets very large, this entire expression goes to 0. So anytime we have x left in the denominator, the HA will be at y equals 0. So this means I want to go on the y-axis to where y is 0 and put a horizontal line through the y-axis at that point. That'll be my horizontal asymptote. Moving on to the x-intercept, that's all about whatever makes the numerator 0. The numerator is simply 4. There's no x's in that numerator at all. So that means that there's no value I can plug in for x that'll make this top thing equal 0. This means there's no x-intercepts, so I need to write none. I'm not going to write 0, I'm not going to write 4. There's not going to be any place where this graph crosses the x-axis because there is no way I could make this top ever be 0 by plugging in a number for x. So there's no x-intercept. For the y-intercept, I am going to look at the ratio, like the last terms. So looking at this expression, I'm going to look at these terms together. So that's going to become 4 over 2. This, of course, reduces down to 2. So the intercept for the y-axis is at 2. So I'll have a dot right here at 2. Now to graph this thing, if you're feeling a little bit lost, the first question you want to really realize is how many sections do you have? There's going to be 2 sections of graph. There'll be some curve on this side. There'll be some curve on this side. On this side, I have the one clue of the y-intercept, and I know I need to approach these asymptotes. So the curve that comes up like this, swoops down through here, and then levels off like this, is hopefully clear. And on the other side, it's actually hard to tell, but there was that one clue we had in class that these would always be diagonal from each other in this class anyways. So I know it's going to go like this. Now if you don't like that and you want something to actually do, pick any of these x values that you want. I don't care which one. But if you take an x equal to negative 3, for instance, and you go back to your original equation, which was 4 over x plus 2, if I let x equal negative 3, I get 4 over negative 3 plus 2. This would simplify to make negative 1. So I get a negative 4. Now that tells me that the graph goes to the point negative 3, negative 4. So I could get a point down there if I wanted one, and then I would know to draw the graph on this side. Good luck.